Hi, you all. I was thinking about our class yesterday, and I feel badly that I gave you a confusing example about the battery, and I got some questions afterwards. So I want to run through and answer some questions. First of all, the reference material that you have, I want to point out, is in the form of oxidation potentials. So we know it's oxidation when a material goes from a lower valence, in this case, if nothing is shown, it's neutral, to a higher valence, in this case, it's 3 plus. So this represents oxidation, and it says the potential for that to happen is negative roughly 1.5 volts. These potentials are relative to one another. So what could happen is if, let's say, platinum was the other electrode and it's coupled to gold, conceivably the platinum with the negative potential could oxidize and the gold could reduce because the oxidation potential would then be, the reduction potential would be plus 1.498. So when you sum the values together, you get a positive number. So remember that spontaneous galvanic cells, the corrosion doesn't happen unless there is a net positive voltage. We talk about half cells or galvanic cells. The basic idea is you have two dissimilar metals in an electrolyte that are electrically connected. In this case, it's showing conceptually you have a light bulb as a load. Electrons are running from one place and being collected in the solution on the other side. This is why there has to be a reducing agent in here in order to actually cause this sort of circulation of electrons. How would you know if I gave you the electrodes which one of these reactions was really taking place? You wouldn't exactly know unless you knew the whole half cell, like what kind of electrolyte was inside. So it wouldn't really be a fair question for me to ask you, for example, is this iron reaction taking place or is this one taking place? This one up here. What I was asking about in class was how would you get more potential out of a specific set of electrodes? And people weren't wrong when they said changing the electrolyte. So I actually, I think, was mixing two ideas. So I apologize. Here's what I meant was if you have, let's say this is only a half of a volt, this reaction in this set of cells, you can string them together in series so that the load can experience a half a volt plus another half a volt plus another half of a volt. So we can get 1.5 volts across these series of individual galvanic cells.